Hey everybody, it's time for street. It's Thursday. It's time for our Astro Coffee Hangout with Dr. Brian Keating. My name's Tony Darnell, and we are going to be talking about the theory of, well, I guess more than one now, theories of everything. And we couldn't do this last time because we had some stupid connection issues. Now we just resorted back to Zoom, our old standby, and things are fine. So let me go ahead and pull Brian up here. You there, Brian?
I am here.
So tell us about why
Hello,
your video
Tony.
looks the way it does, and where are you?
I am in a mountain time zone near Jackson Hole, Wyoming, for a very special event, which will be taking place with yours truly and I don't know, how do you say the other guys truly? Tony and I are going to be part of a very special virtual stargazing event that's taking place tonight,
That's right.
8 o'clock Pacific, 9 o'clock Mountain, 11 o'clock Tony's time, East Coast time.
That's right.
And it's with the most amazing telescopes that any amateur astronomer I've ever met has. This guy's a phenomenal person. He's done tremendous amounts of astronomy with his home observatory, which has almost the same collecting area as the Hubble telescope. And it is very fitting that we're celebrating the Hubble because this is its 30th birthday, as Tony knows. So tonight, every single star party that I
Wait a
used
minute.
to
I
attend
thought
as
that
a
was
kid, or
April 20th. April.
well,
Okay.
it's April, but it's the
Okay.
year. Come on,
Oh,
Tony.
okay. That's a yes. It
Um,
is 30 years. Yeah, in April of 1990, actually, it launched. That's right. So okay.
yeah,
Yeah.
can you believe it? So what we tried to do is celebrate, give Hubble a birthday party, but
Hmm.
also all these star parties that we used to go to as kids and take our kids to, they're all canceled because of that C word that no one can say.
Yeah.
And have their YouTube videos monetized still. So what we're trying to do is rekindle that with a virtual star party where we're going to cover none other than the birthday telescope's greatest hits. So I put some links in the live chat. Tony will put them in his maybe the permanent chat, although it's only happening tonight. So if you
Right.
miss it, you won't be able to catch it live. We'll probably record it,
Right.
but it'll be on my YouTube channel, Tony's YouTube channel as well.
Yeah, we'll be streaming starting at 11 o'clock this evening my time. Do the math on wherever time zone you're in, but that's Eastern time. And I don't know, we'll stream for an hour or two. I'm not quite sure how long we'll be on, but it's gonna after about 2 hours, I'm gonna be fading. I can tell you that. So it'll be
Oh
it'll
yeah,
be 1 o'clock my time. So
no.
we'll see how it goes. So yeah, stick around tonight and join us for this virtual star party. I know that you guys out in Europe will be way late in the morning for you guys, but early in the morning for you guys. But try if you can make it anyway. Okay, so the link to that, by the way, is all on my channel, and if you set the little bell for the notification, you'll get notified if you're on Brian's channel. The link to his channel is also in my description box. Just click on notifying the event on his channel. Did you set the event up yet, Brian? On your channel for
Um,
tonight?
I don't I don't know how to do that. Let's check it out afterwards.
Okay,
If
sounds
you hit the
good. All right.
notification, you'll get it.
Yeah. Theory of everything. So you just did a thing. Why don't you? This was a few weeks ago. You did an online thing with several physicists, and you talked about a theory of everything. Now, when we didn't get connected, I just gave everybody my opinions on this during that stream. So check that out to get what my thoughts are on it. But so tell us about what you did and what was going on.
So, not only was April the birthday of the Hubble telescope back in 1990, but in 1920, in April, there was something called the Great Debate, and it was held in the Smithsonian Institution in Washington, D.C. And it was a debate concerning whether or not the Milky Way galaxy is the entire universe, or whether there are other island universes, large galaxies that are different from the quote unquote tiny nebulae that have the same kinds of appearance that you see through your telescope. So it's a centennial of those great debates. And I made friends with Matt O'Dowd, who runs a very popular channel called PBS Spacetime Studios on YouTube, and you can check that out. And that team, the PBS Spacetime Studios team, and I created a webinar series of two webinars to which I added my own. I'll describe a little bit in a moment about what I did separate from PBS. Kind of, I went rogue, Tony. But it was
No,
all
I don't believe
yeah,
it.
it was all in in an attempt to really capture the spirit of the times, the zeitgeist, Sabine Hossenfelder might say. And it concerned whether or not there is a theory of everything, why there are so many theories of everything. If, as the Highlander says, there can be only one, why are there so many? And furthermore, do we even need a theory of everything, which was asked by a very eminent scientist on this very channel not too long ago, and his name is Tony Darnell. So, Tony, you gave me a homework assignment to consult with the greatest scientist in the world about whether we even need a theory of everything. Do we need an 11th toe? And so I did that. I took the mission up, and I ended up speaking with Lee Smolin, Sabine Hossenfelder, Eric Weinstein, Stephon Alexander, James Beacham, who's an experimentalist who people don't know as well, Max Tegmark, and a tiny bit of Lisa Randall before a hurricane swept through Cambridge, Massachusetts, and took out her internet connection. But she's fine. She assures me she's fine. So the greatest minds in the world that are working on this one problem through different approaches: experimental, theoretical, calculational. And it was a blast. It was a total blast. So I had a great deal of gratitude to those guests and to Matt O'Dowd and his team at Spacetime Studios. They really run a very, very impressive organization there. 2,070,000 or 2,100,000 followers.
Wow. Yeah, that's true. They do some good content as well. So, did you? And I put a link, by the way, to what Brian's talking about in the description box of this stream, so you can go watch the whole thing in its entirety. But so, what's the consensus? What are the answers to some of those questions? Do we even need a theory of anything? Everything theory of anything?
Well,
we might need a
turns
theory
out
of
when you
anything.
it turns out that when you have six eminent physicists, you end up getting 10 different answers, which is kind of surprising. So
10 different
some
theories.
differed on 10 different theories. Yeah, to that question, do we need a theory of everything? The approaches are what really fascinated me, and the question of the impact of mathematics and mathematical simplicity, mathematical beauty, elegance, etc., that seem to be overarching the new theories of everything, namely that of Wolfram, who wasn't a participant in the two PBS episodes, but he instead joined with me and Eric Weinstein last Thursday for a very rip-roaring good time, where we put those two head-to-head. Those are great mathematical physicists, and they debated more, not the virtues of their own individual theories, although it was great to hear, at least to hear Eric explain Stephen's theory of everything, which is that the universe is somehow computational, and that the universe organizes itself along purely computational principles following relatively simple algorithms that can then generate the laws of physics that we observe. Eric has a much more Baroque, Byzantine, complex theory of everything called geometric unity. And it was funny because I invited Sabine Hossenfelder. I don't know if we talked about my podcast with her on this channel.
We did. We mentioned
Tony,
it,
but
but
we should.
And
Yeah.
in fact, Kinslayer on Twitch is saying Sabina savages Eric a couple of times on the stream.
Oh yeah. So just yesterday, she came out with a music video, really kind of chiding him in a humorous way about his theory, and also mentioning Wolfram as well, and Garrett Lisi, who's a friend of mine from he's a graduate of UC San Diego, and remains a good friend. He's got his own theory, this E8 theory, and Sabina is known for being very polite and reserved. No, she's not. She's very curmudgeonly, very much a pessimist. So she savages these theories. Yeah, people are saying in my chat that sparks were flying in that conversation. There were also sparks flying in the conversation with Wolfram and Weinstein, which is very, I don't know if you've ever had guests on where the guests are like, kind of battling each other. People should look at the video. Some say Eric won, some say Stephen won. But the one thing I really appreciate is Eric gave a very good translation of Stephen's theories, especially how we can convert them into kind of simplified, almost Feynman-like diagrams to understand these terms that Stephen Wolfram proposes underlie the meaning of reality. What was interesting is that Stephen didn't want to talk about his theory, and he didn't want to talk about Eric's theory even more. So in the chat, I was kind of negotiating between the two of them. And in the middle of all this,
So
Lex
was it
Friedman.
getting belligerent? I mean, were they like really not wanting to discuss the theories?
No, I think Eric
Was it all
wanted
good
to
natured?
go for everyone. It was mostly good natured. Some people say in the comments it wasn't, but Stephen was kind of particular. He didn't want to talk about the weeds. He said, let's stop talking about this, let's talk about other things. But I wanted to keep going in the weeds because I know my listeners and your listeners can handle it, and I was their voice. And so I was trying to do it, and then I'm getting all these text messages from Stephen. Let's move on. Let's do a different topic. And I love Stephen and his work. So it was a little bit. It was kind of like your parents get into a fight and you're trying to make peace between them. I don't know if that ever happened to you, but it happened to me. I was so unsuccessful. My parents both were divorced twice. But anyway,
Wow.
this theory that Stephen proposes is equally complex. In fact, it might be even more complex. I call Eric's complicated in that you could reconstruct it if you knew enough math. The problem is nobody seems to know the math. And then I had the pleasure of then Eric came down to San Diego. You recall that he's always accusing the physics community of not engaging with him. And so my whole thing is I'm going to put my money where your mouth is, Eric, and we're going to get together and we're going to hash this out. So he came down, masks and gloves, and we went to work, and we just sat at a whiteboard in my house and hammered on these theories of everything and his particular approach to geometric unity. We made so much progress, and we're kind of tentatively agreeing on how we can pursue a joint project together where we would supervise a student to finally get some of Eric's work into publication. And I know that's what my audience wants. I know that's what you guys out there want. I want him to actually write something down. Unlike Stephen, who writes down books that are this thick and that nobody seems to read. But he's obviously very, very successful. So that was kind of last week. And I wanted to give Stephen a chance because people like Sabine are savaging him, and so I wanted to give him a chance. And we didn't have time and space to include him on the Space Time Studios podcast. So instead, we had a one-off, and that's on my YouTube channel and on my podcast channel, Into the Impossible, as well.
Okay. All right. Well, I want to get into something that Alan Lowy on or Lowy, I think, I'm not sure how to pronounce it, was commenting. He says Eric's theory is too complex to be correct, and I want to drill. So my question has to do with why does the theory of everything have to be simple? And what would a characteristic of a theory, just general, what would a characteristic of a theory of everything need to have? I keep hearing that it's got to reconcile relativity with quantum mechanics, the very big with the very small. We've got really good notions of what happens in the very large scales, and we got pretty good notion of what happens in the very small scales, but we can't get them to connect. Is that what it needs to be?
Yeah.
What has it got to be?
Well, so that's a very good question. One thing I think I disagree with the first part of the question, that it's too complicated. I think.
Well, I was just asking, does it need to be simple? A theory of everything.
Well, okay, but yeah,
because Eric's is too complex,
think,
according to Alan.
Yeah, so I'm addressing Alan first. So Alan,
Okay.
Hi. I agree it's complicated, but this is something I didn't really realize until I was a physics, graduate student, that in the 1900s, even the early 1900s, people didn't understand how to use matrices, like matrix multiplication, linear algebra, and things like that, and certainly tensors and vector products, et cetera. Those are very abstract concepts. Einstein had to basically consult with some of the most eminent mathematicians, Marcel Grossman, and others, of course, Riemann, Gauss, and not, he didn't consult with them, they were dead, but he used their work to establish a bridge, a codex, a Rosetta Stone that would translate between the purely mathematical descriptions of differential geometry to physics. So if you were alive back then, Alan, and there was a deep astronomy, coffee table, because there wouldn't be a podcast, you might say, oh, this is too complicated. And yet, with that, Einstein was able to unify, or at least provide a mathematical underpinning that unified mathematics, pure mathematics, differential geometry, to understand how space-time curvature affects the dynamics of motion. So, so I would say complexity, as you describe it, may well be true, and it may apply to me. I'm an experimental. I'm just a simple, humble experimental cosmologist, right? So I'm not a mathematician, but on the other hand, I think it's extremely important to go as deep as we can and try and understand the limits of what we can know in mathematics, understanding that the ultimate test is experimental. And that's where all six of these people kind of come up short, in my opinion. They'll all say, oh, well, the ultimate test is experimental, but then they'll say, well, we need a collider in the case of James Beacham, the size of the solar system or something, or to actually test something. Or they'll say, we need this $20 billion future collider. And Sabine will say, well, that's $20 billion down the drain because there's no natural target. You're just going to say, here, we pour money in here and out comes serendipity on the other side. And I agree with her in that context. It's not enough to just say we're going to find new things. So I'm getting questions in my chat room from Konstantinos, how much do I believe Eric's theory? So, again, belief is always the wrong word. So the question is evidence. So his theory makes very specific predictions about the nature of things as important to me as dark matter, as antimatter. And those things have to be reconciled with the theories of, or the observations that we have of dark energy, dark matter, new particles, etc. So I've proposed ways that we can test it. But first, I really need to understand it. And a lot of it, I understand kind of this almost tapestry threads of it, but I don't understand the whole of it. So that's why I'm going to recruit a bright graduate student in the coming year to help me translate this into experimental and moreover cosmological predictions, Konstantina. So that's when I'll be able to say I can have belief or evidence for it, or it might be impossible to ever get evidence for it. And in that case, that's the main question, because then that diverges from the traditional scientific method. I think that's what irks you, Tony, so much.
Yes, I don't like things that can't be ultimately dealt with observationally or in any other way. So, do these things have to connect? I mean, do we need a theory of everything? Yes or no? In order to do science, do you think there is one, and do we need one?
I think at this point, what we're guided by is the fact that there are unifications of electromagnetism, of electricity and magnetism, and the weak theory. There's there are gut theories. There's the SU2 cross SU3 cross SU2 cross U1. And those are all group theory structures. Those are incredibly successful. The thing that's missing from that. So if you said you've got I'm trying to make a good analogy here. If you have something that gets you're reading a book, and the first three chapters, it's progressing, it makes total sense, everything needs to be coming together. The story's really good. It doesn't lose your interest. You can't stop turning the pages. And then the fourth chapter is just like totally out there. It's about, the Iran-Contra affair. And this is like a murder mystery that takes place in Cancun. And you're, what the heck is going on here? It doesn't play nice. So the expectation after the first three chapters is that the fourth chapter will be like the first three. But maybe it's totally different, right, Tony? I mean, there's no law of nature that says we have to have a law of nature that can be written on our T-shirts.
That's right.
But what I think is important is that I see from all these mathematical physicists, I see very little chance that that there are other theories that are plausible, testable, falsifiable, other than these theories. In other words, there's kind of like, there's a difference between something that's complicated, Tony, like building a 747, and something that's complex, like trying to build a sandcastle. Like when you build a sandcastle, every time you build it, it's different. And it depends very sensitively on that very first sand grain you drop down. That forms the base. It's called sensitivity to initial conditions, is a hallmark of complex systems. Now, building a 747 isn't easy, but if you follow the blueprints, you'll build the exact same one every single time. It doesn't matter if that day was a Tuesday that you started and it was raining, or it was a Wednesday and it was sunny. So that's the difference between complicated and complex. I think there's an abstract notion in my mind that the theory of everything will either be complex or complicated. Eric's theory is very complicated. It uses, these 14-dimensional structures. It uses mathematical projections. It uses all sorts of notions of what dark matter and dark energy would be. That's very complicated because you have to learn the structure of math. You need a math PhD essentially, although I don't have one. And I believe I can't see the end. I can't even see the beginning of the end, as Winston Churchill said, but I can see the end of the beginning. And in that sense, it gives me hope that he's spanning the vector space of possible theories of everything that are complicated. Does that make sense? But Wolfram spans the perpendicular direction in Hilbert space or mathematical theory space. And those are theories that are complex. So I think some of those people, one camp will be right. I noted as I was listening to the debate, kind of separating the fighters from when they went toe to toe, pun intended, I said, one of these guys, they can't subsume each other's theories. Only one can be right. And they didn't want to, kind of fight each other, but I think they believe that too, that they're right, the other guy's wrong. And that's fine. You need a little bit of confidence, almost arrogance, to make progress in this field.
Well, and that's also how science is done. I mean, somebody's right and the rest are wrong, and it'll come out in the process. So that's what's supposed to happen anyway. Uncle Bill's commenting, we have been spoiled by the simple elegance of Kepler, Newton, and Einstein. That does not mean the next step will be so elegant. Personally, I think it will be, but that's wishful thinking. And that's true. We have these biases, sort of all the time. And it's like Kinslayer saying, I think it does have to reconcile gravity and quantum and doesn't need to be simple. It needs to be testable and verifiable. That's a good comment. And We Be Good says, yes, it will be simple and elegant. So there's this preference for simple and elegant things that make us happy and feel good and that we can put on a t-shirt. I am far from convinced that any of this is necessary, but again, we're not complete. We need a more complete view of what's going on in the universe. We clearly don't have that yet, so this will get us closer. And if it really does connect one thing to another and doesn't make us have to depend on strings and multi-worlds, then yay. Do any of these go there? I mean, do any of these theories that you were talking about with Eric, and they all go there? So we end up somewhere that's basically fantasy land?
Well, look, when you look at Wolfram's theory, so he's got this theory that describes complex systems in terms of simple-looking mathematical laws. They're not simple in the sense they're fundamental in the sense that an electron is a fundamental building block of nature. It doesn't mean it's simple. To understand an electron, you need Dirac equation. You need these things called spinors. You need the notion of Hilbert space. So all these different things are necessary to describe something that's elementary. Like if you went to elementary school and they start teaching you about Hilbert space, I got a recommendation for another school. So it doesn't mean easy. I mean, in this case, Wolfram, what he has done, it's tantalizing, because he describes a theory that is successful at describing fractals, crystal growth, biological systems, entropy. And so I asked him, well, what makes you think that it has something to say about the underpinnings of the laws of physics? In other words, will you get out of it the fundamental constants of nature, the mass of the electron, the speed of light? And to some of those he said yes, and to some of those he said no. He said yes to certain things like quantum entanglement comes out of his theory, and it's nowhere present. Well, I shouldn't say. I'll say it's nowhere present in somebody like Garrett Lisi's E8 theory. It actually, Eric says it is present in geometric unity, and I have to think really hard about that because I don't yet. I haven't seen that mountain peak yet. But Garrett Lisi is just kind of a mathematical. It's more akin to like SU5 or superstrings. It doesn't encode within it the laws of quantum entanglement the way that Stevens and Eric's eventually will.
Okay, so by definition, a theory of everything is a connector of all the theories we currently have. Will a theory of everything be a starting point? Can it be the first principles from which everything that we know now can be derived. You've alluded that some things come out of some theories, right? Quantum entanglement comes out of, I think you said Eric's theory. But can these theories of everything, whichever one, if there is one and if it's the right one, will it serve as a first principle from which we get everything else, or is it just a connector of things that already have their own sets of first principles? We can derive Maxwell's equations from what we know in E&M. We can derive theories in relativity, and even I think Schrodinger's equation from first principles, right? So will this theory serve that function, or will it just be a connector of things we already know?
Both Eric and according to both Eric and Stephen, yes, it will be able to do things such as the quantum entanglement, the Schrodinger equation.
You start with their theory and get those things.
Yes, okay. They are products of their theory. Okay. Eric's theory, it's not so clear that you can get the Dirac equation, but you can get entanglement allegedly. You can get things that Stephen's theory doesn't have. Which is to say dark matter. Eric has a theory that dark matter owes its origin to this chiral asymmetry. The asymmetry between your left and right hand there's a similar analog to that in the properties of particles, in that we only see left-handed neutrinos. Do you know that that's true, Tony? Do you know how you can remember that you only see left-handed neutrinos?
No, I don't know the answer to that.
So, do you know that DNA has a helical structure?
Right.
And do you know what kind of helix that is? Left or right-handed helix?
No, not off the top of my head.
So DNA, this is the way to remember it. You'll never forget it. So DNA has the right to life. Okay, so it's a right-handed helix.
Oh.
And the neutrinos are the opposite. So they're left. You're sinister. Neutrinos are sinister, ghostly product. Correct me in the chat room if I'm wrong.
Okay.
But that's a cool mnemonic? Anyway,
mnemonic. Okay. Yeah.
So Eric's theory presupposes that their dark matter is essentially opposite chiral particles. So those would be right-handed neutrinos, and those would not interact with ordinary matter in the same way that chiral left-handed amino acids aren't digestible by ordinary bacteria, and that's how things like artificial sweeteners work. And so there'd be this sort of different dimensionality that would be a parallel universe to the ordinary matter universe, and those would explain why we don't see dark matter. Now, Stephen's theory, as far as I know, doesn't explain that, but what it does explain is why the speed of light is what it is.
Okay.
And that actually is so it's different. What we'd like to know is how it's possible to get. I think, Tony, a lot of times these theorists kind of oversell themselves. Like when you say a theory of everything, I, like you, would want to have an explanation for all the laws of physics. But that's not what they mean a lot of times. Some of them do.
It's not unreasonable for a theory of everything.
I think what they mean is,
otherwise you got a theory of some things, right? You got a theory of a couple things.
The problem is that the problem is that they use the grand unified theory terminology, gut. They use that already. So they can't really, but that's actually what it is in most cases. In string theory doesn't presuppose, that the outcome of it's going to be Schrodinger's equation. It basically this, supersymmetric 10-dimensional space. It's more like Eric's theory, and Eric's theory is more properly named because it doesn't call itself theory of everything. And actually Stephen doesn't call his a theory of everything. And so none of these are really true theories of everything. That doesn't mean they're not important. That doesn't mean that they're not very interesting. Because what if I said to you in 1897, that the week for 1857, that electricity and magnetism are the same thing? You'd say that's silly. Mm-hmm. If I then proved Maxwell's equations, that they're just manifestations of the same underlying force field, you would then say, well, they're unified. So that would be a unified theory. But you wouldn't say that's a theory of everything if we were just electronic beings. Yeah. So it doesn't Maxwell's equations don't have within them Bell's paradox and things like that.
No, but I'm just saying that these theories that we do have can start somewhere, a first principle. Electricity, magnetism, they have these these properties, and then you write down those properties, and from there you end up with a set of equations that describe the entire field. And that would, to me, if you're going to have a theory of everything, then you're going to need to end up with your starting point of your theory and ending up with everything. Otherwise, it's a theory of some things. So, how is this going to play out, do you think, Brian, in science? You've got some really unorthodox people, and by that I mean they sort of are on the outside of mainstream scientific community, Eric and Stephen, and then you have others who are working within the community. How's this going to play out, and is it really all that consuming to most physicists, or is it just something that they, kind of play around with once in a while? This theory of everything.
I think it's very important.
Yeah.
It's very important. Let's stop calling it the theory of everything. Let's just call it like the next generation theory, because I don't think it's truly.
This is what we're trying to do. We're trying to unify everything. This is what's trying to happen. So I think we should stick with that because that's what we're trying to do.
Well,
right?
We can call it that. Yeah, but we can call it that. But let's understand, we don't mean in any case. So let's take string theory. String theory has sucked the wind out of all of physics theory, or most of physics theory, leaving very little attention, oxygen, if you will, for other projects, other things like Eric's, right? So now that, again, so let's just stick to things like that. So now why is that? Is that because it had kind of the first mover advantage? Is that because it was so mathematically elegant and attractive that it was hard to resist? The question that we have, to really answer is one of sociology, because in part what happens is we get a certain amount of attention on a specific theory, and then many young people have to choose what they're going to do for their PhD. And they go in and they do their PhD for somebody that's in that field. And there are very few people, all three of these people that I mentioned so far, and even Max Tegmark is kind of outside the realm. The most conventional one that's operating in this paradigm is Stephon Alexander, but he also, he doesn't come up with new theories of everything, but he explores the cosmological implications of them. And in the case of Lee Smolin, Eric, and Stephen Wolfram and Garrett Lisi, they don't have a single graduate student. They're all outside of academia. So why is that? Why is that coming? Why do they have now? It could be because there's such a dominance of the prevailing modality of approaching this, which I think they claim has proven to fail. In other words, they claim string theory has had no successes. It only works in extremely contrived situations called ADS, CFT, universes that are collapsing. You get all sorts of interesting behavior. You get symmetries, you get strings, but there's no evidence for any of that. There's no super particles that have ever been found. So my good friend Jim Gates, he's into even more abstract notions of symmetries, and basically treating the universe as a fractal and looking at its more complex features rather than complicated features. And he's the pioneer in some sense, one of the fathers of supersymmetry. And he's not fully, kind of behind it right now, because I think there's a lack of evidence that this is going down the right track, as beautiful as it is. We just don't have that. And you see that in cosmology too. Yeah. You see people have a dominant paradigm that they pursue, and that the people that are outside that doesn't mean they're, because they're, Einstein was in the patent office, and I'm working in the post office, not to denigrate the post, but that doesn't mean that just because you're outside of mainstream, that you're right.
That's right. Yeah. Okay. So I'm glad to hear that you're getting some interest with young, up and coming students in this, and I think it's the right thing to do, to be an advisor for somebody to study this as a career, because that's what it takes. That's how it gets done. Like you said yourself, people who go into the field, they need to decide what they're going to do, what they're going to work on, what their interests are, and they need an advisor to get them going. And if there aren't people in mainstream academia doing this, then they're not going to get noticed, and so, or they're not going to get started themselves. So I'm glad to hear that you're doing this with the you're just going to try and recruit one student, or maybe several.
I'll probably start with one.
Yeah.
Steven's asked me if I have time and capacity to help do the similar thing with his project, I would
Okay.
love to do that. But I have a day job, which is running, a large lab group
Right. I
and
know. Yeah.
serving with as one of the co-leaders of the Simons Observatory, which is $100 million project that we hope to build in Chile in the next 3 years. So these are, that's my day job, and I have to pay, my attention to that. And
And you're doing a
that's
lot
a
of
two.
SciComm too. You're doing a lot of really good stuff to let us know about what's going on. So that's cool too.
Yeah, well, thanks to you, my
Yeah.
channel's really grown. I started the year, I had 100 subscribers, and now I'm pleased to say I have 8,100 subscribers.
Yes,
So
good.
if this
Keep
keeps
going.
up,
Go. If you haven't subscribed, go do it. Link in the description box. All
yeah,
that.
please
Go.
do.
It's a
Yeah,
good channel.
I
He
want
does
to beat
good
out,
stuff.
PewDiePie or whatever. Yeah, I need to beat
Pew
him
pew.
this
Yay.
year.
Yeah. Or Dr. Disrespect, who is now on YouTube as well. So yeah, we have a lot of star power here. Okay. Well, I know we got to go soon. What were the? Give us the big high altitude look at what this discussion, how it went, and how they can see it, and all that kind of stuff before we leave. Let's send people to the right places.
Well, I was very glad that there were opposing forces. So Sabina is against Eric, Stephen Wolfram, Garrett Lisi. Then there's a guy, James Beacham, who's the experimentalist. He was against Sabina and feels she's detrimental to physics because she's basically raining on this whole parade of building a future collider. Then you have people like Lisa Randall, who unfortunately, her time was cut really way too short on this live stream, but we hope to have her back. And she's got great ideas in what's called effective field theory that we haven't heard from. Max Tegmark is brilliant, but he's I think he has this notion that essentially the universe is mathematical. So of course we should strive to look for mathematical elegance. There should be mathematical symmetries that are observed, and he's a very deep thinker, very creative thinker. Stephon Alexander had very cogent things to say about the state of where do we go from here and the value of experiment in this field, even though he's a theorist. And then, Matt O'Dowd, who's a righteous astronomer in his own right, he and I were going really deep, and that channel is very good PBS Spacetime, exploring extremely complicated topics. What I came away with is a sense that, unlike Sabina, that we should not should not have an outsized effect. The fact that so many people are looking into what she says and taking what she says, to heart. I think we need to be a little bit careful in terms of how much influence a person can have when that person has, by her own admission, not taken the time to really want to understand the theory. Now, I can understand that because there's only so much time in the day. But on the other hand, she'll say things like, these are wrong, but I'm not going to explain why. And then she'll do a rap video or whatever. She's a unique person. And I do appreciate the fact that she's so bold and courageous. On the other hand, I would like these to keep going. I'd like to have more of these with other people. I see in the chat room, people are asking me about Roger Penrose. I asked him to be on. I asked Jan 11 to be on. Katie Mack, all these others, and we're hoping to provide more of these in the centennial year of the Great Debate, the anniversary year of it. And there are extremely important. I asked people like Ed Witten, who I didn't get a reply from, Nima Ahmed Arkani, who did reply very graciously, but he wasn't available. And so I think we're going to get more interest in this. And I think the question is, can Eric put this to paper? Can Stephen find applications outside of biology, mathematical complexity theory, crystallography, etc.? Can, Garrett Lisi, can he, is there any traction, or is there any time that these people can say that this aspect of my theory is wrong, but now I see that there's another avenue that's more promising? That's what I want to see. I want to see more of that. The only other thing I have to say is that we're never going to be able to test these using colliders. I'm sorry. These things that we already know we can't test with a collider. And so the question of, what do we do? There is one resource that we have yet to take full advantage of, and it's called the entire universe. And I think cosmology will be the proving ground for future theories of everything. And so I'm kind of putting in a plug for people to not only explore, does my theory of everything predict the Schrodinger equation? Of course, that's awesome and it's great. And even if you don't predict it, even if it's irrelevant, like it is to supergravity or whatever, still predict something in cosmology, either at extremely early times or extremely late times, predict properties of dark matter, dark energy, because those we can test today. We have outpaced the rate of growth of progress in particle physics in our experimental cosmology laboratories, such as the one that I run at UC San Diego.
Great. Okay. Well, good. I would encourage you guys to definitely get over there, watch the whole discussion. This has just been a brief
There's three of
intro,
them, yeah. Hmm.
brief intro
Yep.
into it, and to kind of wet your whistle. I hope you guys will check it out.
And tonight, don't forget.
Yeah, don't forget tonight, 11 o'clock. I will be with Brian. He'll be running the show, and I'll just be sitting there waiting to talk about different things. And I'll be streaming this on my channel and chatting with you also on my channel. So join me tonight, 11 o'clock Eastern. Next Thursday, and Brian, I need to let you know this too. I've got another guest coming in for a Thursday hangout for Astro Coffee.
Okay.
So we'll have to pick up in a couple weeks. I'm talking with Matt Kaplan from Illinois State University, who's going to talk to us about black dwarf supernovae, and
Oh, wow.
I wanted to read about that, or I wanted to learn more about that after I read the article. So he's going to join us next week,
Awesome.
and we're going to talk about that. So, and we'll be back in a couple of weeks after that to pick up where we left off. So, okay, guys,
Great,
11 o'clock
Tony.
tonight. I will be there, and thank you all so much for watching. And on behalf of Dr. Brian Keating, thank you so much for hanging out with us. And as always, keep looking up. Okay.